Hey guys, this is Jeff Feemster from Feemco Technologies. Um, Wanted to go ahead and make a little video tutorial here about how to identify files when you just simply don't know what they are. Um, Came across an issue today where I had some interesting files. I don't know what these are. This says some EDF file, like the extension for it. Um, Extensions, when it comes to computer systems, extensions aren't really standardized as much as people seem to think they are, because you could use PDF file and actually have anything with that file name or with that file extension. There has been, more stuff nowadays that actually identifies the inner workings of it, and that's what we're looking at today. We're looking at how the file structure works, how different things can be seen within a file to really kind of understand what's going on. Whenever you see just any old file that you've never seen before, especially in like forensics, malware analysis sort of field, you kind of got to do, how would I say, you kind of got to rely back on older techniques of really looking into how it's structured, how structures work, and I guess you could call that a little bit of signal intelligence. So first off, what we're going to do here, we can always get some idea of what's going on from the format, from the extension. Like this says .crc, um, some hexadecimal data that we don't really have any information on. I assume this is a cyclic redundancy check, a hash that's basically validates that the information in the related file has not been tampered with. Um, so then we look at this file. These were all these were all three files within the folder that we just looked at. This is all from an SD card, and this SD card, for context, is actually from a CPAP machine. So we're kind of digging into what we expect to be just general medical data, this sort of stuff, right? So here we automatically see some spaces between these. Um, it shows up as some dots. Hold on, let me make sure that this shows up on screen actually. Gotta move this around some. So this will show up over here. All right. Maybe this will be a better way to do it. All right. Go ahead and shrink my view a little. All right. So as we're looking at this, we see some data here. We see 0A000A, right? And in string format, these refer to escape codes that are used for creating new lines. So this may actually load inside a text editor. And so let's go ahead and do that. Let's open that up. Let's go to E drive and let's open this in a text editor. All right. So inside this file, we see there's, here's the new lines we saw. And we see here's the same sort of information we saw there, right? We don't necessarily know what any of these mean, what they're relevant to. This looks like kind of a product name of some kind, so this might be like a serial number or something, maybe a board number. I'm not real sure. Uh, so we could kind of guess at that. It's perfectly fine to take guesses. You don't got to make any assumptions that are like finite and permanent. You just make a guess and kind of say, okay, let's run with that for now until we can prove it. We kind of have a rough idea of what that is. It's just some basic information about the system that this came from. And so on this file, we have a little bit different. Here we actually can instantly see some different structures. Um, we see a bunch of 20s there. 20 usually means space. So let's go ahead and let's do find binary. Let's do 20. Now, this isn't actually binary, that's hexadecimal, but you get the point. Binary is easily translated to hexadecimal, which is then represented the way we see it. So, anyway, each section of 2 is 1 byte. Each section like this is 8 bytes. Each section all the way across is 16 bytes. You can see this down here at the bottom. Let me make sure that actually shows up. Down here at the bottom, you can see that that's the thing. Um, Actually, let me go ahead and move this again. I'm going to move it right to the center. So we see some date information, we see some start information, then we see just a bunch of what seems like table headers to me. You know, if you had a database, you could see these being like the top row of the database or like a CSV file, right? Um, and then we see a bunch of like empty space, and we see some little stuff here and there. Then we see a whole different structure down here. We see a bunch of zeros down here, a bunch of F's, but what appears to be a totally different structure. And sometimes it's really common within file types and file formats where they have here's all the header information, all the information you need for the rest of it, and then just here's the data dump, you know. Um, a lot of different file formats do this, so I'm not too scared. We got this, right? Now, what interests me about this one is that at the very start of the file, we see back here at the very start, we see this starts off with a 0. It's really weird for a file to start off with a 0. Usually you'll have what's called a magic number or a like file type identifier there. This may not be very useful for that. And if it is one, then, you know, it may be that this doesn't always fit for this. So I wouldn't really want to use this for making a Yara rule to detect these files because anything could use that. You know, you could have a text file that shows up like that. So anyway, you have a 0 that starts there. Then you have some X's, question mark, um, some whatever data. Then you have some other stuff around here, and let's really look into what all that could be. Let's go back over to find here. Let's search all the 20s so we can understand where that's all at. Um, we instantly see some data here, then a space to separate them, then we see some more data. So maybe it's all space delimited, just from a guess. Well, as it turns out, I kind of did some Googling on this and found some neat stuff here. Uh, if I can find the thing again. All right, so full specification of EDF. This is public online, kind of neat. There's like a whole download section where you can like get different stuff about it. Um, but I didn't know what this file format was, so I'm looking at this like, okay, well, guess we got to look into it. You can also look at RFCs or requests for comments. You can find this information for a lot of different formats. But let's just go through this header section real quick and let's try to see what exactly is going on. We do see that there is a header section and a record section. So from that from that we can kind of assume that that lower section we looked at is definitely where all the data is, right? So to start with, we see eight eight characters of ASCII version version of this data format, 0. So, and okay, 0, got it. Uh, Next 80 characters. Just wanted to come back and clarify a part real quick. I realized I had messed up. Uh, I looked at just the 0. It should have been the first 8 bytes. And then the next 8 bytes would have been these. And so that would have put that as the version number. Still doesn't mean anything. It's still kind of useless. And then this being the patient data. What it says is local patient identification. I don't think those X's are going to be relevant. Um, it kind of seems more like they put in a placeholder for that. Whatever. Um, okay, but then actually part of that is still a 20 and part of this is still a 20. So we actually know that the 20s aren't necessarily delimiters, they're just part of the actual data. So then we have this say start date. So what does this say here for the next one? Next 80 characters are local recording information. Okay, so we go down here, we find the next 80. Okay, that makes sense. So local recording information. We have start date. We have some kind of information about it, I guess. We saw some of those, like the SRN and the stuff like that, on that previous page. So maybe that's kind of just referencing that. Let's go ahead and make a bookmark for this so we can highlight it for ourselves and come back to it later, just in case we ever need it. Um, then we're going to come through and say, okay, what's next? We got 8 characters for this, 8 characters for that, and then another 8 characters for that. Okay, so let's find the exact end of that. Okay, now 8 bytes for this doesn't seem right. Might have meant to be started there. Or maybe this whole thing should have started later. We see this here as a date in the format that it mentioned. So this part's a question mark. And this part we know is the next part. So maybe for parsers, you got to just ignore the extra 20s. I don't know. We'll see. Um, so we go through here. Let's make another bookmark for this, for the date. Then for the next one, we see this 8 here. But then over here on this side, it almost looks like that would have been like a, nanoseconds or, hours, seconds, minutes, whatever. But that doesn't seem to be relevant. So what's this next one after that? So that's number of bytes in header records. So this section from here is actually relevant to how many records will be there. So let's bookmark that, and we can always go over to our bookmarks and like name them. So like if we wanted to say record count, oops, and we could even go ahead and change the colors if we want, make it show a little bit better. Um, that way we can kind of keep track of what's going on with this. And as we just kind of slowly parse through this whole thing, we can kind of see different information about it. Make sure that I can actually see all this on page. Okay. Um, so we don't got to go through all of this, but let's see here. The next 44 are reserved after that. So we had this, which seems to show EDF, some sort of EDF comment, whatever. Um, 44, so just before that next thing. So this part, which is interesting, is going to be another thing we should keep track of, because that's the reserve part, and only thing that's in that reserve section is EDF. So maybe that's for like an extension or like for future versions or like version differencing, whatever. Could be anything, right? Um, then the next 8 are going to be number of data records. So these bytes here, so 498 data records. Okay, and we can also come over here and look at each of these through different data types and say, okay, well, is that a integer? Is that 52 of them? or is this more likely to be 498 as a total number? Um, Given that it has a certain limited size here, I would assume that the the idea is that you can only have a certain size, like it only have a certain amount, because once it reaches past that size, it would be pushing over into the next section, which file format exploits happen all the time. Um, so, that's basically what you do. You just go through the whole thing. You try to understand what each thing means, how it's used, and ultimately, all of this seems to just point to, here's data about the file that it's then going to read later. Um, what I found out with looking around and, researching a little bit on all of these, um, the actual additional specifications on here give you some uh, kind of much needed insight. Like for some of these, the number of data records can only be -1 during recording. Um, as soon as the file is closed, the correct number is known and must be entered. That's really interesting that it says that, because that means that anything that parses these or records to them is required to do this. Um, a lot of times with file format stuff, they either fail to do this, or there's a um, limited part where they can do it. So interesting stuff. There's some stuff about timestamps. Um, so yeah, that's how you kind of dig into this, and you just keep researching it until you fully understand the whole file.